In this video, we're going to go over how to perform a mystery solutions lab. This one specifically dealing with double replacement reactions, but you can use the principles of this example to do single replacement as well. We've got our solubility rules, and I'm going to go fast with solubility rules because I know my solubility rules. So you may need to pause the video from time to time to look up at the solubility rules, and that's totally okay. You're going to be given 3 known solutions, and when they're known solutions, that means that they will be labeled. And you're going to be given unknown solutions, and they're going to be labeled, but they're going to be labeled as maybe A, B, or C, or maybe 1, 2, and 3. Okay, so they don't have their chemical formulas on them. And our goal is to cross these and figure out the identities of A, B, and C. Okay, and so there's a specific way that we can go about doing this. And if we look here, I have created a table, which is something that you would need to create on the Mystery Solutions lab that we're going to do next week. And how this works is I'm going to cross them in either a double replacement reaction, which is what we see in this lab, or we could see, like next week's lab, we could also cross them with a single replacement reaction. And the way you know if it's a double replacement or a single replacement is if you have 2 compounds, like we have here, they will react most likely in a double replacement reaction. Let's say instead of this being silver nitrate, it was silver, and then we would know that we would be performing a single replacement reaction. Okay, so what I want you to do first is I want you to think about the ions that are present, because in a double replacement reaction, it's simply just the ions that are being swapped. So we have Ag plus 1, and we have nitrate, NO3 minus 1. We have calcium plus 2, just from the periodic table, and we have carbonate, CO3 minus 2. We have hydrogen, H plus, and then we have sulfate, SO4, 2 minus. We have ammonium, NH4 plus 1, and we have chloride, Cl minus 1. We have hydrogen, H plus. We have chloride, Cl minus 1. We've got calcium again, and Cl minus 1. And what we're going to notice is that when we cross these, we're going to get a unique pattern, or what I'm going to typically refer to as a fingerprint, something that's unique to that chemical that we can use to identify. So for example, when we cross silver nitrate and ammonium chloride, we are going to get silver chloride as a product, and we're going to get nitrate with ammonium, so that'll be ammonium nitrate. If you remember the rules of double replacement reactions, we need a solid, liquid, or gas to be formed in order for the reaction to occur. If I look at my solubility rules, chlorides are going to be always aqueous except with silver, lead, and mercury. So this will be a solid, and then all ammoniums and all nitrates are going to be aqueous, and so we get something like this. So what we're going to get is I'm going to box this, and I'm going to call it PPT to mean precipitate. Okay, that's a solid that's formed in a double replacement reaction. Now, let's cross ammonium chloride with calcium carbonate. So calcium is going to go hang out with chloride. We're going to get CaCl2. We'll figure out the solubility of that here in a minute. Carbonate's going to go hang out with ammonium, and we're going to get ammonium, NH4. We need 2 of those. Carbonate. We need to figure out the solubility or the states of matter of these. Calcium chloride, go ahead, figure that out from your solubility rules. And ammonium carbonate, figure that out. And when you figure those out, they're both going to be aqueous. And so this is going to be no reaction. Okay, when we mix those two, sure, we're just going to have a bigger solution, but no product or evidence of chemical change is going to occur. Okay, now let's mix some more. We're going to take hydrogen, H plus, mix it with chloride. We're going to get HCl. We're going to take ammonium, mix it with sulfate. We're going to get NH4, 2, SO4. Hydrogen chloride is aqueous. Ammonium sulfate is aqueous as well. And we get no reaction. So for this compound, ammonium chloride, its unique fingerprint would be When we cross it with silver nitrate, calcium carbonate, and hydrogen sulfate, we're going to get precipitate, no reaction, no reaction. That is its fingerprint. Okay, we're going to notice that things are going to give different fingerprints as we work through this. So when I make hydrogen chloride mixed with silver nitrate, we're going to get hydrogen nitrate, HNO3, plus silver chloride. The solubility of this is going to be aqueous and then solid, so we're going to get a precipitate. We're now going to mix hydrogen chloride with calcium carbonate. Calcium's going to go hang out with chloride. Hydrogen's going to hang out with carbonate. We're going to get H2CO3. And you may remember from last class that H2CO3 is kind of this weird guy that's going to form H2O and CO2 gas. So the reaction actually does happen even though hydrogen carbonate is aqueous. And so what we're going to see is we're going to see carbon dioxide gas in the form of fizz. Okay, so now I hope you can sort of see how the fingerprints of ammonium chloride and hydrogen chloride are going to be slightly different. This one is precipitate, no reaction, no reaction. And then this one, the hydrogen chloride here, is going to be precipitate and then fizz. And now that's different than what we had above, so we can differentiate those two. But let's keep going. We're now going to mix hydrogen with sulfate, and notice how we're going to get H2SO4, which is what we had to begin with, and then hydrogen chloride. So we don't get any new products here, so it's going to be no reaction in addition to two aqueous products. Okay, so that is its fingerprint. Precipitate, fizz, no reaction. We've got one last one. We're going to take calcium and mix it with nitrate. We're going to get calcium nitrate. And then we're going to take silver and mix it with chloride. We're going to get AgCl, and that's going to be a solid. Solid in a double replacement reaction is referred to as a precipitate. Okay, let's mix calcium chloride with calcium carbonate. We're going to get CaCO3, that will be a solid, plus CaCl2, aqueous, and so now we have another precipitate, and now its fingerprint is slightly different. If we continue on, we're also going to get calcium sulfate, which will be a solid as well, and we're going to get hydrogen chloride, and so this fingerprint is going to be different as well. 3 precipitates, precipitate, precipitate, precipitate. And so we have 3 unique patterns for our 3 unknowns. This might be A, this might be B, this might be C, and so we can differentiate them. As you work through this and then work on the Mystery Solutions Lab for 2021, you're going to do something very similar. The only difference is you're going to then have a single replacement reactions to perform as well to differentiate using your activity series. It may be a little bit tough to work through that, but that's not something that you can't do if you work at it, okay? So, good luck. Let me know if you have any questions. Send me a Schoology message to let me know you got to the end of the video, and I'll give you some bonus.